Tech in 5.
Dive into Python with a fun game, learn in just 5 minutes.
Are you ready to create the timeless classic game, Minesweeper? Minesweeper isn't just a game of luck. It's a symphony of strategy, patience, and critical thinking. And guess what? You're going to learn how to build it from scratch. Our journey begins with understanding game states. In game development, each state has its own rules, its own look, and its own purpose. For our Minesweeper, we'll focus on two main states: the menu state, where you'll choose your difficulty, and the game state, where the action happens. First, let's take a look at the main file. When the game runs, we start with the menu state, the initial gateway to our Minesweeper adventure. Notice how we prepare our window with the reset window method? This function resizes our game window to fit the chosen state, ensuring a seamless transition. Now, let's dive into the heart of our game, the main loop. Here, in the event handling section, we listen for player inputs, such as clicks and key presses. Each state has its own handle event method, tailored to its unique needs. The real magic lies in the state transitions. With the update method of the current state, we check if it's time to move on, to switch from the menu to the game, or vice versa. This is where our game decides its next move based on player actions. And finally, we bring our state to life with the draw method. Whether it's the calm of the menu, or the thrill of the game, we draw the current state, ensuring our players are always at the center of the action. Our loop runs continuously, with PyGame's display flip method ensuring every frame is updated, capturing every moment. And there you have it, a loop that cycles through states, listens, updates, and renders, showcasing the endless possibilities of what you can create within this structure. In the menu state, players make their first decision, choosing their challenge level. In the heart of our menu state lies the button class, a fundamental piece that players interact with to choose their game's difficulty. Rect is the button's position of X and Y for the top left corner, along with width and height, determining where the button is and how big it is. Text and color represents how we label the button, and what's its default color. Notice the change in color as the mouse hovers? Here, we use a simple yet effective technique to detect if the mouse cursor is hovering over a button. The collide point function checks if the current mouse position falls within the button's rectangle. When the mouse cursor is over a button or moving away, we change its color, creating a visual cue that the button is interactive. Once the button's color is set, we draw the button on the screen, filling the button's rectangular area with the current color. Then we create a font object and render the button's text using the text rectangle and screen blip method. The isClicked method is where the action happens. It also relies on collide point to check if a mouse click occurred within the button's boundaries. If a click is detected within a button's rectangle, it signifies that the player has made their selection, allowing us to proceed with the corresponding action. In the initialization method, our buttons are created, each representing a difficulty level: easy, medium, or hard. Whenever players click the mouse, the handle event method checks if the click happened on any of difficulty buttons. If a button was clicked, the game transitions to the game state corresponding to the chosen difficulty level through the singleton setup. Right after selecting the difficulty, reset window method adjusts the game window size to fit the new state perfectly. In the reset window method, the set mode method is used to define the size of the game window. By passing a tuple, we instruct PyGame to adjust the window's dimensions to 600 pixels wide by 600 pixels tall, providing a suitable space for the menu screen. The update method checks if a difficulty level has been selected. If so, it returns the game state object to transition the game to the chosen difficulty. Lastly, the draw method brings our menu to life, displaying each button on the screen for players to choose their Minesweeper difficulty level. In this video, we've laid the foundation of our Minesweeper game, focusing on main file and the menu state. In our next video, we'll dive into the game state, where the real challenge begins. Join me as we continue building our game, step by step. See you in the game state.
Stay tuned for more videos on Tech in 5.